Hi everyone, welcome to lecture 2 of week 12 of this Smart City course. The topic for this lecture is the blockchain. The blockchain is one of the most talked about and misunderstood technologies in the public life today. By the end of this lecture, you will able to understand exactly what this blockchain is and why it matters for the city governance and where it is being already used. So let's start with an example. Suppose your family wants to buy a piece of land. You find a seller, you agree on a price. Now you need to verify. Does the seller really own this land? Has it already been sold to someone else? Are there any court cases or loan on this property? This verification currently requires months, lawyers and office visits. Because whatever these records are, they are in the paper or sometimes in some incompatible government database formats, which can be altered very easily. The blockchain solves this. Imagine a public notice board where every land deal is written. Thousands of people each hold an identical copy of this notice board or of this record. If one person secretly tries to change their copy, everyone else's copies are different and the change is very simply or easily detectable and it can be rejected. That is actually the blockchain. It is a digital record book shared across thousands of computers simultaneously where the records cannot be changed once it's written. Now let's see how does this blockchain works technically. Let us go through it step by step. Now each records in blockchain is called as a block. Every block contains a transaction detail, a timestamp and a hash. Now hash here is a unique mathematical fingerprint of that block. If we change even one letter in a block, and the fingerprint of that block changes completely. Now the blocks are also chained together. Each block contains the fingerprint of the previous block. So if you change block 500, the block 501's reference to it will break. The whole network immediately detects that some tampering is going on. For a new block to be added, most computers in the network must agree that it is a valid record. This agreement process is called a consensus mechanism. Now there are two main types of consensus mechanism. One is proof of work. Here computer solves a difficult mathematical puzzles to validate. This is a very secure, but it uses a lot of energy. The other approach is the proof of stake. The validator here are chosen based on their stake in the network. This is much more energy efficient and this is actually the preferred for government applications. There are also two types of blockchains, public blockchains and private blockchains. The public blockchains are open to anyone like cryptocurrencies, and the private or the permission blockchains restrict access to authorized persons only. Typically, this second or this public blockchains are preferred for the government users. Now let's see how the blockchain can transform the land records. So land records are the most impactful blockchain application for Indian scenarios. The land dispute are among the most common cause of court cases in India. The fake documents, multiple times selling, missing records, these are the widespread problems. Blockchain tries to fix them in three ways. First, by creating the immutable title records. So every transaction from original land grant is permanently recorded. No insider can alter this historical record. Also, it can streamline the transfer process. So smart contracts can automate the transfer process. When buyer pays, stamp duty is confirmed, and both parties sign the contract digitally, the title updates automatically. What takes months today can take hours. The third, it can reduce the dispute. When everyone or anyone can verify the complete ownership history of a land, many disputes simply have no ground to stand on. The blockchain applications on the land record may reduce 70% property dispute, and they can also reduce around 90% of processing time. The Andhra Pradesh was the first Indian state to pilot this. Georgia, the country, has run its full national land registry on the blockchain technology since 2017. The blockchain for the land record sounds great in the theory, but there are certain real challenges. There are challenges associated with the technicality. So there is a issue with the system integration. Now in India, we have land records available in different format. In the British era, there might be land records available in the handwritten formats. Later on, there are some records which are available on the Excel files, or maybe some other incompatible databases formats. Now migrating all of these onto a blockchain is difficult. Same time, it's expensive and it can cause certain errors on the data. Now, one wrong boundary measurement or misspelled name on the records, which are going to be permanently recorded on an immutable ledger, can be a serious problem. Also, there are challenges associated with the legal framework. Here in India, most states do not recognize the blockchain record as a legally valid record. That's why a legislative update is needed in this area. Then other challenges are associated with the organizational. So there are issues with the stakeholders training. Whatever the government staff, lawyer, banks and citizens are involved in these type of transactions are not aware of the technology. So that is why they need to be educated for this blockchain technology. Also, there is a challenge of a digital divide. The elderly landowners in the rural areas without a smartphone or internet can not access or use the blockchain only systems. So that's why the multi-channel access is essential for those peoples. The recommended approach here is to implement this blockchain technology in phase-wise manner. The first phase could be where we can have pilot in one district with applicable for new registration only. Then in next phase we can expand to the specific property types. In third phase we can have the city-wide rollout after learning from the earlier phases. Now let's see how this blockchain can be implemented in public procurement. So government purchasing includes tender, contract, supplier payment, and this is one of the most corruption prone activities in any administration. The blockchain can address this failures in three main points. The first is it can avoid any kind of tampering of the tendering process. All bids can be recorded the moment they are submitted and cryptographically sealed. No one can alter a bid after the deadline, not even the official who received it. Because of this, there could be prevention in corruption. Every procurement decision is on a transparent, immutable ledger. Bid rigging or kickbacks are much harder to hide when the complete audit trail is visible to anyone. Also, a public audit trail can be established. The citizens, journalists, and any oversight bodies can verify the procurement decision in real time. This can result in 15 to 25% cost saving, 50% faster processing, and 100% audit coverage with zero tampering. Also, by using blockchain, one can trace the supply chain. The blockchain can track materials and goods from manufacturer to delivery site. This can ensure the quality and can prevent any bad kind of material in public works. The smart contracts can automate the entire procurement workflow, from publishing the tender to releasing the final payment. This may include automatic payment release whenever the payment executed automatically when delivery is verified. No manual approval needed, no delay and no dispute. Also, whenever the policy requirements are embedded in the contract code, that policy or that contract codes automatically enforces. No human can bypass them. So that is why this blockchain can automate the compliance. Also, it can track the supply chain. So every step, whether it is shipping, delivery, quality inspection, payment, is logged automatically and permanently on the record. The World Economic Forum had demonstrated a full procurement smart contract, where tender published, the public comment period automatically enforced, the bid recorded with cryptographic hashes, automated scoring for all the bids, and based on this scoring a bidder will be or a winner will be selected. Here all the records are permanent and the entire process happens without any human discussion at any critical points. The benefit of this process is it can fast the processing with very less amount of manual work. Also, there will be enhanced trust through a verifiable history, and there will be fewer disputes because the enforcement is automatic. Now, to access the government services, we require to prove our identity multiple times to multiple agencies using multiple type of documents. Aadhaar has helped us in this regard, but still our identity is stored and controlled by a central government database. Now the blockchain enables a different model here, which is known as the self-sovereign identity, where we own and we control our own identity data. Here, citizen can control their own credentials, date of birth, addresses, qualification, license. These all are stored in a kind of digital wallet, not a government server. And one can decide who gets access to which kind of data and whom to revoke with the access of this data. Also, there is one time of registration which is required. One verified digital identity can work across all the government department and services. Also, it uses the selective disclosures. So using zero knowledge proofs, you can prove a fact without revealing your underlying data. You can prove you are higher than of age 18 without actually showing your date of birth. You prove you live in Indore or whatever the city without showing your home address. In Estonia's e-residency program, they established a global benchmark for this technology. India's Aadhaar shows the scale and achievability. Combining Aadhaar's reach with blockchain citizen control is the next frontier which we are looking for. Now let's see the privacy and verification side of digital identity. Now the privacy features user control. You decide which credential to share and with which organization. Now privacy, the encryption and the data minimization protect the personal data stored. And revocation, you can withdraw access to your data at any time. This can be used in document verification, where blockchain enables instant tamper-proof verification of credentials, no phone calls, no office visits, no manual checking. It can be done for the academic degrees verification also. The universities issue a verifiable digital credentials. Employees confirm them instantly without actually checking your degree, and no fake certificates no faking of certificates can be done. Also, the same can go for verifying the professional licenses. A doctor, engineers or lawyer license can be verified in real time by any authorized party. Also, all the government document which is issued, like the birth certificate, the passport, the driving licenses, could be tamper-proof and can be instantly verified. The balanced approach here will be the transparency for fraud prevention combined with the citizen control over the personal data. The best system or best digital identity uses cryptography to verify without exposing unnecessary information. One more exciting application of this technology is peer-to-peer energy trading. Now, currently we have problem. If you have a rooftop solar panel and generate more electricity than you use, you sell the excess back to the grid at a lower government fixed rate. Now you have no choice about the price or the buyer. The blockchain enables directly the trading between the neighbors. Let's see how it works. So in first step, your solar panel generates excess amount of energy. In step 2, a smart contract automatically matches your supply with the neighbor who needs the electricity. The step 3, power will flow through the grid from you to your neighbor. In step 4, a payment executes automatically whenever the power delivery or energy delivery is confirmed. No utility company will come in between. This can result into 20% lower energy cost, 30% increase in the solar panel adoption, because the financial return will be now better if you trade the energy by peer to peer. Brooklyn microgrid in New York is one of the example of this peer to peer trading. In India, we have PM Surya Graha scheme, which targets 10 million homes with rooftop solar. The blockchain P2P trading would make solar panels much more financially attractive after applying this technology. Now let's see what is the benefit and economical impact of the blockchain for energy. The three main benefits of the blockchain energy trading are: it can lower the consumer cost. Removing the intermediate markup reduces the energy cost by up to 20%. Also, it can increase the renewable adoption. Better financial return can make the solar panel more attractive, driving a 30% increase in the solar installations. Also, it may improve the grid stability. The local trading between the neighbors actually reduces the pressure on the main grid. The less power needs to travel long distances. This will reduce the transmission losses. There are also the economic impacts, around 50 to 20% reduction in the energy waste. Also, the market will be more democratized because the new small scale participants will come into it. This will accelerate the renewable transitions by 5 to 10 years. There are certain challenges as well. The energy market is heavily regulated. New laws are needed for this P2P trading. The technical grids upgrades are needed to handle two-way power flow. Also, the consumer education is needed so household can understand how to participate. Let me be honest about blockchain's limitation. It is powerful for right problems, but not a solution for everything. There are certain associated challenges. First challenge is its scalability. Bitcoin processes around 7 transactions per second. Visa processes around 24,000 transactions in this time. A city scale system needs much higher output. Newer blockchain architects are addressing this, but it remains a constant. The second challenge is associated with the energy consumption. Proof of work blockchain uses enormous electricity. contradicting the sustainability goals we have adopted for smart cities. The most government application uses proof of stake instead, which is more energy efficient. The third challenge is associated with the regulatory uncertainty. In India, there is no comprehensive blockchain law available. So legal validity of smart contracts, liability for smart contract errors, admissibility of blockchain records in court, all are still uncertain. The fourth challenge is associated with interoperability. The different blockchain platforms cannot easily communicate. Risk of creating a new data silo instead of solving the existing one is always there. The third challenge is associated with the digital divide. The blockchain requires digital access and literacy. System must have alternatives for the people without a smartphone and literacy about the internet as well as internet. So to summarize this lecture, we can say the blockchain is permanent, tamper-proof, transparent digital records which can be shared across many computers. The best government applications for blockchains are in land records, public procurement, digital identity and energy trading. The key tools which are useful are smart contracts that can be executed automatically whenever some conditions are met. This can result in around 70% fewer property dispute, 90% faster processing and 15 to 25% procurement cost. The main challenge here is scalability, legal recognition and legacy system integration, and also the digital divide. The key test before using blockchain is, do we especially need records that no single authority can control? If yes, blockchain. If no, a well-designed database may be better. Thank you so much. That's it for this lecture.